Okay, let's dive in. Imagine looking up way back and seeing creatures in the sky. I mean, far grander than any bird we know today. Just enormous. Today, we're on a mission, really, to explore this groundbreaking paleontological find. It's genuinely putting Japan on the map for, well, for giant prehistoric flyers.
It really is. And what's so exciting is that this isn't just another fossil fragment. It's actually the very first time a pterosaur has been formally named from skeletal remains found in Japan. That's
A
huge.
huge milestone, yeah. It sort of redraws the map for these ancient animals. We're focusing today on Nipponopterus mifunensis. That's the name. We'll get into its unique features, where it fits in the ancient world, which is maybe surprising, and also the really cool international teamwork behind figuring it all out. And just so you know, we're drawing this from a new paper in Cretaceous Research, a proper peer-reviewed journal, and details straight from the researchers. So maybe let's rewind a bit, because this discovery, it actually goes back decades, doesn't it?
It does, yeah. We're talking about a single neck vertebra found way back in the 1990s in Kumamoto Prefecture.
One bone from the 90s. So what makes this bone so special? What did they finally figure out when they took a closer look?
Well, it's amazing what one bone can tell you, especially when it's looked at with, modern techniques. This is the sixth cervical vertebra, the sixth bone in the neck, and its shape, its morphology, is just incredibly distinctive. They used advanced CT scanning.
Ah, okay. To look inside it.
Exactly, to see the internal structures and fine detail. And it revealed these really striking features, almost like anatomical fingerprints. For instance, on the top surface, there's this prominent raised ridge. They call it a dorsal keel.
A keel, like on a
Yeah.
boat. What does that suggest on a neck bone?
Sort of, yeah.
Yeah.
Its prominence points towards some seriously powerful neck muscles attaching there, which, hints that Nipponopterus might have had maybe a unique way of feeding or holding its head.
Okay, powerful neck, unique feeding. That definitely paints a picture. What else did the vertebra show?
Well, underneath that keel, running along the bottom, there's a distinct groove that's called the ventral sulcus. And then at the back, the part that connects to the next vertebra. It's got this sort of subtriangular shape, the condyle.
So triangular, okay. So the shape of that connection point matters.
Oh, absolutely.
Yeah.
It dictates exactly how the bones fit together, giving us clues about how flexible its neck was, its posture, things like that.
Mm.
But maybe the most telling feature, it has these things called post-ex apophyses. They stick out sideways in a pretty unusual way compared to other pterosaurs.
Yeah.
And it's that combination of features, the keel, the sulcus, the condyle shape, and those projecting post-ex apophyses that really clinches the identification. It firmly places it within the Azhdarchidae family.
Ah, Azhdarchidae. Okay, now that rings a bell. Because that family includes the real giants, right? Like Quetzalcoatlus, the
Yeah.
absolutely massive one from North America.
Exactly. You got it. The Azhdarchids are famous for having some of the largest flying animals ever known. And there's also this hypothesis, quite strong now, that they were well adapted for stalking prey on the ground.
Right, walking around on their wings and legs.
Precisely, like giant winged storks almost. So finding Nipponopterus in this family, even though we only have the neck bone, well, it lets us estimate its size.
How big are we talking for this Japanese flyer?
The researchers estimate its wingspan was around 3 to 3.5 meters.
Okay, so about 10 to 12 feet. Not Quetzalcoatlus huge, which was, what, 30 plus feet?
Yeah, Quetzalcoatlus was in another league, maybe 10 or 11 meters wingspan. But 3.5 meters is still substantial, way bigger than any bird flying today. A significant predator, likely.
So a medium-large, powerful-necked Azhdarchid pterosaur found in Japan. That really does shift things, doesn't it?
Yeah.
Especially for our picture of ancient East Asia.
It's a major step, yeah. Really crucial new insight into just how diverse pterosaurs were in that part of the world.
So if we connect the dots, finding an Azhdarchid here and knowing they're also found in places like Mongolia, North America, what does that imply about the world back then? About how these things got around?
It definitely suggests these creatures were incredibly widespread. The presence of this family in Japan during the Late Cretaceous points to a wider distribution than maybe we fully appreciated. It hints at, possible connections,
Right.
like land bridges that aren't there anymore, or island chains they could hop across. It really opens up questions about how these massive reptiles dispersed across the globe.
Wow. It makes you think about these ancient superhighways in the sky, doesn't it?
It really does.
Mm.
And the whole process, from finding that bone in the 90s to finally giving it a name now, It's a story about patience, but also about collaboration.
Yeah, you mentioned the international team. That seems key here. How did that work?
It's a fantastic example of science crossing borders. You had researchers from Japan, obviously, where the fossil was found and kept safe all these years. Then expertise from China, perhaps in comparative anatomy with other Asian pterosaurs, and researchers from Brazil contributing maybe phylogenetic analysis expertise, figuring out its exact place in the family tree.
So bringing different skills together.
Exactly. Combining specific knowledge, different technologies like the CT scanning, analytical methods, it just accelerates the whole discovery process. It shows how much more we can learn when we work together globally.
It's kind of amazing. One neck bone sitting in a collection for years, holding all these secrets.
Until the right combination of technology and expertise came along.
What a journey. Okay, so let's just quickly recap the key points from our deep dive. We've got Nipponopterus mifunensis, the first pterosaur actually named from skeletal bits found in Japan, late Cretaceous period.
Yep. Identified from that single, very distinctive neck vertebra found back in the 90s in Kumamoto Prefecture.
And it wasn't tiny, estimated 3 to 3.5 meter wingspan. A member of the Azhdarchidae family, related to giants like Quetzalcoatlus.
And that's huge for Japanese paleontology. It gives us vital new clues about pterosaur diversity and evolution in East Asia. Plus, the research itself using CT scans, detailed analysis, it's a brilliant showcase of international collaboration. Japan, China, Brazil, working together. Science transcending borders, really.
And those specific features of the neck bone, that big dorsal keel on top, the groove underneath, the special shape of the joint, and those sticky out bits, the post-exapophyses.
Right, those unusual projections. They're the key anatomical markers that helped place it so precisely.
So thinking bigger picture again, what does finding this creature, and Azhdarchidae related to ones in Mongolia and North America, what does it really make us wonder about?
Well, it poses that important question, doesn't it? About how interconnected the world was back then. How did these massive flying reptiles manage to spread so incredibly far across the globe? What were the pathways? It really fuels the imagination about their dispersal.
Ancient connections and lost worlds. Amazing. And if you, listening, want to connect with this piece of history yourself.
You actually can.
Yeah. The actual fossil vertebra of Nipponopterus mifunensis is now on public display. You can go see it at the Mifune Dinosaur Museum in Kumamoto Prefecture, Japan. A direct link to the Cretaceous skies.